In this video, we will sketch the gradient vector fields of various functions. So this video will be very similar to the previous one. We'll just be sketching vector fields, but with one additional step, we have to first come up with a vector field. Here we're not given a vector field, we're given a function of two variables. So we first have to write what the gradient of the function is, and then sketch that. So, in part A, the gradient of this function, we just take partial derivatives. The x derivative is 1, and the y derivative is 2. Now the thing to notice for this particular example is that these are both constants. There's no x's or y's here at all. That means it doesn't matter what point we're at. The vector field will always be the same everywhere. So at every single point, the vector will be 1, 2. So it'll point up and to the right, over 1 and up 2. And that's going to be at every single point. So at every point, just draw the same vector that goes over 1 and up 2. So it's just a bunch of parallel vectors all pointing in the same direction. And here's a picture. It's not too hard to imagine. Okay, on to part B. Here, well, let's first multiply this function out. If we square this, this is x squared minus 2xy plus y squared. Now, if we take the gradient, the x derivative is 2x minus 2y, and the y derivative is 2y minus 2x. So let's try to imagine what this looks like. So let's take this point for instance, 1, 0. So here it will be 2, negative 2. So it will point down and to the right. How about if we pick minus 1, 0? Then the x-coordinate will be minus 2, and the y-coordinate will be plus 2. So it will point like this. How about if we pick 0, 1? Then we'll get minus 2 and positive 2. How about if we pick this point down here, 0, minus 1? Then we'll get plus 2 in the x, and for the y, we'll get minus 2. So, parallel to the first two vectors we drew. About 1, 1 and minus 1, minus 1. Here, well, that'll be 0, 0, because we have x minus y and y minus x. So along this line, the line x equals y, the vector field would be 0, and we just don't draw any arrows at all. How about like over here, 2, 1? What'll that look like? Well, 2 minus 1 is 3, so that'll be 6 for the first. And here, 1 minus 2 is negative 1. So we'll get negative 2. So it'll point to the right a lot and down a little bit. So something like that. And we could keep going and keep going. You get the idea. And eventually we would see a picture like this. And just as we noticed, you don't see any arrows here on the diagonal, because when y equals x, we get 0, 0. And you see the rest of the pattern here, as we saw. Okay, finally let's look at part C, x squared minus y. The gradient here is 2x comma 1. So here the y component is constant, but the x component is not. That means that every vector we draw will have y component 1. All the arrows will be pointing up. But the amount of x direction that the arrows point will vary. So for example, along the y-axis, when x is 0, all of the arrows will just be 0, 1. They'll all just point straight up. But if we go to the right, say when the x value is 1, then all the vectors will be 2 comma 1. So they'll all point like this. And if we go here where x is minus 1, they'll be minus 2, 1. So the same thing but reflected. And if we go, say, to x equals 2, they'll be 4 comma 1. So it'll be even steeper, or less steep, closer to being horizontal. And if we draw enough, you'll see something actually, oh, this picture is upside down. It's because I made a mistake. It's x squared minus y, so this should be constant minus 1. So actually, rather than redraw it, let's just note this entire picture should be upside down. The y component should be negative 1 everywhere, but the x components are all correct. So we'll get a picture like this that's upside down of what I drew.